Welcome back to the POW-Mister channel. In this video, we will walk you through the display screen operation of the ESS 12 kW 16 kWh solar energy storage system. After powering on the system, the main page shows an energy flow diagram in the center. This diagram helps users quickly understand the current operating status of the system. For example, you can see the PV1 PV input voltage besides the PV icon. And you can see the battery voltage and battery SOC besides the battery icon. By observing the energy flow lights and arrows, users can easily see whether the battery is charging or discharging and whether grid power is available. By tapping the four icons on the energy flow diagram, you can view more detailed real-time information for each comprehensive part of the system. Next, let's look at the three main sections at the bottom of the homepage: Data, Device Information, and the Settings. First, enter the Data menu. In the real-time data page, you can find comprehensive real-time information related to the device, alarms, current, temperature, voltage, and communication status. The statistic data page summarizes the system's daily and cumulative statistics, including battery charge and discharge amp hours, inverter running time, bypass running time, and more. These statistics help users perform long-term performance analysis and comparisons. The historical data page focuses on long-term accumulated records, such as battery charge and discharge amp hour, inverter operation time, bypass operation time, and energy consumption. The event log page displays fault events, including error codes, the time when the faults occurred, and related voltage and current data. This information helps users analyze the cause of the fault based on the corresponding error code. The control page is mainly used for system control and maintenance operations, such as time setting, data clearing, system reset, and manual equalization charging. Next, let's move to the device info section. This page displays information such as the device hardware and software versions, UI version, device serial number, system voltage, and language settings. After connecting to Wi-Fi, you can also check for updates on this page and update the system software and UI version if available. Finally, let's enter the setting menu, which is the core configuration section of the ESS. Under communication settings, since the system is currently operating as a single unit, there is no need to modify the device communication address. The ESS has built-in Bluetooth and Wi-Fi communication modules. You can enable or disable these functions using the toggle switches on this page. The LCD backlight set time determines how long the screen stays on before automatically turning off when there is no operation, helping reduce unnecessary power consumption. Since the system is currently running as a single inverter, the RS451 parameter and RS452 parameter do not need to be configured. The time segment page is used to set time of use charging and discharging schedules. Users can define when the system charges from the grid and when the battery supplies power to the load based on local peak and off-peak electricity prices, helping reduce electricity costs. The battery settings section does not require manual configuration. The system is already pre-configured to match the battery pack, which simplifies the setup and reduces installation time. Next is system settings, which should be configured according to the power requirements of the load. First, let's look at the system parameter section. Under AC output mode, there are three options. Mains priority means the grid mainly supplies power to the load, and the battery only supplies power when the grid is unavailable. However, this priority does not affect utilization of the solar power. Inverter priority means the battery and inverter supplies power to the load first. When the battery voltage drops below the preset threshold, the system switches to the grid power. Once the battery is fully charged or reaches the recovery voltage, it automatically switches back to the battery supply. During this process, solar power is still fully utilized. PV priority means solar power supplies the load first. When PV power is unavailable or the battery voltage falls below the preset value, the system switches to grid power. The AC output voltage can be selected according to the load requirement, within a voltage range of 100 to 130 volts. The frequency can also be adjusted according to the load requirements within the range of 45 to 65 Hz. If the hybrid load function is enabled, the system will automatically switch to mains priority mode, allowing both grid power and PV power to supply the load simultaneously. Since the parameter function of this ESS is still under internal testing, the parameter mode and the parameter phase options do not need to be configured at this time. Next is battery charging mode. Hybrid means the battery can be charged simultaneously by PV and grid power. Mains priority means the battery is charged by grid power first, and PV charging will only be used when grid power is unavailable. PV priority means PV power is used for charging first, and the grid will be used only when PV is unavailable. Photovoltaic only means the battery can only be charged by solar power. The charge current limit controls the maximum battery charging current. This limit can come from three sources. SAT, which uses the inverter's configured charging current limit. BMS, which allows the real-time limit provided by the battery management system. Inverter, which follows the inverter's internal derating protection logic. The mains charging current limit sets the maximum charging current when charging from the grid. By adjusting this value appropriately, users can balance charging efficiency and grid electricity consumption to help reduce electricity costs. The BMS protocol is already pre-configured at the factory and does not require any changes. PV output priority determines whether PV power is prioritized for battery charging or for supplying the load. BMS communication fault shutdown means that if communication with the BMS fails, the inverter will automatically stop output to protect both the inverter and battery. This function is enabled by default. The AC input mode does not need adjustment. This range is compatible with both APL and UPS applications. For grid type, the current single unit system supports 240 volts/120 volts, so no changes are required. Next is the system function section. The NPE ground shorting function enables or disables automatic N2PE bonding. This should be enabled in regions where such grounding requires apply. When energy saving mode is enabled, if the ESS output remains below 50 watts for 5 minutes, the system will shut down the AC output and enter energy saving mode. After 30 minutes, the system will automatically restart output and monitor the loads again. To exit energy saving mode, users can either disable this function manually or restart inverter output by turning the inverter module off and on again. Automatic restart after overload allows the ESS to restart automatically after an overload shutdown. Automatic restart after over temperature works similarly, allowing the system to restart automatically after a temperature protection shutdown. The buzzer alarm setting controls whether the audible alarm is enabled or disabled. The mode shift alert triggers a buzzer notification when the power supply priority changes. For example, when the battery voltage drops below the preset level and the system switches to grid supply. If overload bypass function is enabled, the system will automatically switch to grid bypass to supply the load when an overload occurs. That concludes the display spring operation guide for the ESS 12 kW 16 kWh solar energy storage system. Thanks for watching and we will see you in the next video.